Hi, everybody. My name is Matt May, and I am a California Climate Action Corps Fellow stationed at the Reed Climate Center. And I am also the lead of the Biochar Bar. Today, I will be introducing you to the Biochar Bar program. The Biochar Bar is one of our regenerative labs and exhibits, programs designed to showcase regenerative tools and practices that align human systems with nature. We will talk about what biochar is, how it can be a tool for climate resilience, and how REAP aims to incorporate biochar into its vision for creating climate job pathways. The REAP Climate Center's mission is to increase access to climate change mitigation by providing ecological experiences and climate job pathways. At the highest level, REAP Climate Center envisions a world where all human-built systems align with nature. Engagement is key to our strategy. We focus on three main points of engagement: volunteering, curated experiences, and workforce and training. Together, these engagements create a pathway for curious individuals to develop their interests into skills and experience in nature-based solutions work. As of August 2024, REAP's Biochar Bar is in the development stage. This program has come a long way from REAP's inception in 2020. Since then, we have researched the biochar industry, connected with biochar producers, and learned how biochar is being used to address climate change in California. First, let's understand what biochar is. Biochar is created when organic material, often forest and agricultural residues, is heated in the absence of oxygen, a process known as pyrolysis. The product of this process is a stable, carbon-rich material that can be used to improve soil health, sequester carbon, and capture pollutants. Biochar's properties provide benefits for soil, water, and biodiversity. First, biochar converts a substantial amount of carbon from biomass into a stable form, which can then be removed from the atmosphere and stored in soil for centuries. In addition, biochar has porous, microscopic structure, which provides a great amount of surface area to contain water, air, nutrients, and microorganisms. This can improve the aeration and water retention capabilities of soil, provide a habitat for microorganisms, and even retain nutrients and act as a slow-release fertilizer. The material can also be used to absorb harmful substances such as heavy metals or organic pollutants. Biochar's benefits make it an effective tool for mitigating climate change and addressing other climate risks, such as drought, erosion, and pollution. Our aim at REAP is to showcase the full spectrum of biochar's capabilities, to not only mitigate environmental threats, but also to revitalize ecosystems, enhance biodiversity, and create a sustainable future. Biochar has proven to be an effective soil amendment that improves soil structure, enhances nutrient retention, supports microbial activity, and increases soil pH in acidic soils. This allows it to be useful for restoring degraded agricultural soil, reducing the need for chemical fertilizers, and creating targeted changes in soil for plant growth. In addition, biochar is also an effective tool for forest management due to its ability to enhance resilience to wildfire and effectively manage excess biomass. California forests have an excess of flammable material that become fuel for wildfires. Producing biochar from this excess material can assist in reducing wildfire risks by converting forest biomass waste into a stable form of carbon, thereby decreasing the amount of flammable material in the forest. In addition, this biochar can improve the health of forest soils to prepare for new tree growth. We have already explained how biochar directly reduces atmospheric CO2 by sequestering carbon in the soil. In addition, biochar indirectly aids in carbon sequestration by enhancing soil health and promoting plant growth, which increases the uptake of CO2 by plants. It may also indirectly reduce emissions by replacing fertilizers and other industrial products which are very carbon intensive. Biochar is effective in environmental remediation due to its ability to absorb and immobilize contaminants. Its highly porous structure provides a large surface area for trapping pollutants such as heavy metals, pesticides, and organic compounds, preventing them from leaching into groundwater and reducing their bioavailability in the environment. This makes it effective material to be used in remediation projects, such as restoring polluted industrial sites or improving water quality in polluted watersheds. Biochar can also be used in green infrastructure due to its ability to retain and filter pollutants from stormwater. Just as it removes pollutants in contaminated soils, it can also remove pollutants from water. Additionally, biochar supports the growth of vegetation on green roofs, urban gardens, and other green infrastructure projects by providing a stable source of nutrients and enhancing soil fertility. These properties make biochar a valuable component in sustainable urban planning and green infrastructure, contributing to the resilience and environmental health of urban areas. Biochar is produced through various methods, each differing in scale, efficiency, cost, and byproduct capture. Small-scale traditional kilns are low cost and accessible and suitable for local or community use, but they generally have a lower efficiency and output. These kilns often produce biochar with less precise control over quality and yield. In contrast, large industrial facilities utilize high-tech pyrolysis systems that require significant upfront investment but offer greater efficiency, higher yield, and better quality biochar due to its precise control over production parameters. High-tech systems also capture valuable byproducts such as greenhouse gases, bio-oil, and biogas, which can be used for energy generation or further processing. Biochar is potentially versatile technology for removing carbon at a large scale due to its long-term durability, accessibility for small and large-scale production, and its variety of co-benefits for soil health and the supposed low barriers to verification in the carbon markets. The 2023 Global Biochar Market Report, jointly released by the International Biochar Initiative and the U.S. Biochar Initiative, reveals that the biochar industry is experiencing significant growth. Key findings include a production rate of at least 350,000 metric tons annually, representing a 91% compound annual growth rate from 2021 to 2023. The industry's revenue exceeded $600 million in 2023, with projections to grow to nearly $3.3 billion by 2025. This growth is primarily driven by biochar's role in carbon dioxide removal and as a soil amendment. This growth indicates a pathway whereby biochar could sequester up to 1 gigaton of CO2 annually by 2040, demonstrating its potential as a scalable solution for carbon dioxide removal. However, the biochar market in 2023 faces several significant challenges. A key issue is the need for greater engagement in voluntary carbon markets, as many producers are not yet generating biochar carbon removal credits, limiting financial incentives and market integration for biochar as a carbon sequestration tool. In addition, developing high-quality markets for physical biochar is another hurdle, hindered by low awareness among users and limited access to capital, which restricts the ability of biochar companies to scale operations and invest in advanced technologies. The diversity of production technologies, ranging from small kilns to large industrial facilities, requires tailored strategies and support to ensure all skills can thrive, necessitating inclusive policies. Additionally, the industry must focus on developing standards, enhancing policy advocacy, and gaining governmental support to build trust and integrate biochar into broader climate action frameworks. Addressing these challenges requires coordinated efforts in education, policy, advocacy, and financial support to improve market scalability and effectiveness. There are also risks in large-scale deployment of biochar, including potential alteration of soil pH and nutrient dynamics at a large level. This could eventually harm plant growth in microbial communities if it is not properly studied. The substantial biomass required for biochar production may lead to unsustainable harvesting and deforestation. Additionally, uncontrolled pyrolysis processes can emit pollutants, affecting air quality and reducing CO2 in the atmosphere. Biochar application might also disrupt local hydrology by changing the soil water retention properties. And lastly, the long-term impacts of biochar in various soil types and climates remains uncertain, necessitating ongoing research and monitoring to mitigate unintended ecological consequences. The biochar bar at REAP serves as a regenerative lab and exhibit where people can learn about and engage, as well as train for jobs to deploy biochar as a nature-based solution for climate resilience. Overall, it's a place for training, collaboration, and innovation in the application of biochar. Due to its many applications in the aforementioned industries, we see biochar as a valuable technology that can aid practitioners for a variety of purposes. Farmers may incorporate it into their soils to improve soil health and increase crop yields. Environmental scientists may continue to study its potential applications. Urban planners may incorporate it into green infrastructure projects to reduce pollution and restore contaminated sites. And policy and carbon specialists may continue to support biochar as a technology for large-scale carbon removal for climate change mitigation. We invite you to join us, the REAP Climate Center, in promoting biochar jobs for climate resilience. Whether you are a biochar expert, a practitioner or enthusiast, there are numerous ways to apply biochar across agriculture, infrastructure, and beyond. Let's collaborate to harness the full potential of biochar. Thank you very much.